So this is part 2 of the review. I have done the first page and a half. This is the back of the second page. We're starting with reflections, and we're going to finish up the rest of the review. So this is the stuff that was mostly on the second quiz, while everything we've covered up to this point on the other video dealt with the first quiz. So let's see what we can do with this. Here we go. Reflections. Graph the line of y equals 2x plus 3 on the coordinate axis. Remember, this y is equal to mx plus b. So my y-intercept is 0, 3. My slope is 2 over 1. So go up 2, right 1, up 2, right 1. Or you can go down 2, left 1, down 2, left 1. And this is my line of my original graph. Okay? Number 2, draw the line of y equals x in the coordinate plane. Remember, the y-intercept of this line is 0, 0. My slope is up 1, right 1. So that's the graph of y equals x. Just 3 points that lie on the line 2x plus 3. Well, my y-intercept was the coordinate 0, 3. This point here is the coordinate 1, 5. And then this point down here is the well, let's do this point right here, is the coordinate -1, +1. Okay. The reflected line, remember, if we reflect, we flip our x and our y. So 0, 3 becomes 3, 0. 1, 5 becomes 5, 1. -1, 1 becomes 1, -1. What do you notice about the coordinates? The corresponding points, x and y coordinates, flip. Okay, graph the reflected line. I have these 3 points. I can graph these 3 points. So I have the point 3, 0. I'm going to do this in green. I have the point 3, 0. I have the point 5, 1. And I have the point 1, -1. And if I wanted to do another point, there is -2, 1 becomes, excuse me, -2, -1 becomes -1, -2. And so, and this is the point -3, -3, which is on the line. There is my reflection. Okay, so that's through number 5. What is the slope? Again, y equals 2x plus 3. The slope was 2 over 1, or 2. What is the slope of the reflected line? Remember, x and y is flipped, so 2 over 1 becomes 1 over 2. What is the y-intercept of the original line? We had said that was the coordinate 0, 3, and I have been accepting just 3. What's the x-intercept of the reflected line? Y's become x, so 0, 3 becomes 3, 0. What is the x-intercept of the line y equals 2x plus 3? Well, let's go up here. The x-intercept is somewhere right around here. I'm going to mark that in black. It's right here. It looks like it's like between -1 and -2. If I want to be very precise, remember, to find the x-intercept, we let y equal 0 and we solve for x. So you subtract 3. So -3 is equal to 2x. Divide by 2. And x is equal to -3 halves, which is the same as -1.5, which is what that point looked like, -1.5. That is my x-intercept of the original line. So that's -1.5, 0. Well, what is the y-intercept of the reflected line? X's and y's flip. So this is 0, -1.5. So what is the equation of the reflected line? Well, I have the slope and I have the y-intercept. So y is equal to 1/2 x minus 1.5. That's y equals mx plus b form. That's the first 9 questions. Square root function. Use the graph. Use your graphing calculator to graph the parent function y equals square root of x, then graph the additional functions in the table, fill in the blank. All right, I'm going to pull up my handy dandy calculator. I'm going to move this over here so it's out of the way, get rid of the recording. I'm going to go ahead and hit second clear. I'm going to make this a generic window. I'm going to hit zoom 6 so that my window goes from -10 to 10, -10 to 10, counting by ones. I'm going to get rid of these equations. I'm going to plug in my parent function. My parent function is the square root of x. I'm going to graph. That's what my parent function looks like. So I'm going to go back to y equals. I'm going to plug in the square root of x. Now, for the first problem over here, this is the square root of x plus 4. The plus 4 is outside of the square root, so I need to put plus 4 outside my square root. I'm going to graph, and it moved it up. So what we say is this shifted or shifts up 4. Now I'm going to go back to my graphing calculator, and I'm not going to hit graph. I'm going to hit second graph to go to the table menu. I'm not looking at y1. I want to look at y2. So I'm going to arrow up until I see the word error. I'm going to go right below error. So that means for my domain, x's are greater than 0. And for my range, y's are going to be greater than or equal to 4. So x is greater than or equal to 0. Y is greater than or equal to 4. My original graph did something like this. This one starts at 4 and does something like that. Those are those two graphs, approximately. All right, let's do the third one. Go back to y equals. Now the minus 4 is inside the square root. So let's go ahead and go x minus 4 inside the square root. I'm going to go ahead and now I'm going to do this in y2. I only want to see 2 at a time so I don't get myself confused. So I'm going to say minus 4 here. So I'm looking at the parent function, y equals the square root of x, and then the third one down, y equals the square root of x minus 4. That's the parent function. That's minus 4. Notice my origin, my original point here, has shifted 4 to the right. So x minus 4 shifts right 4. I want to see what this does to my domain and range. Since it's shifting right, I'm going to guess, or I know that it's going to change my x. But to double check, I'm going to hit second graph to go to my table. And look at my x. The word error for y2 is now over here. So right below it, my x's are going to be greater than or equal to 4. My y's are going to be greater than or equal to 0. So I can come back over here and say x is greater than or equal to 4. Y is greater than or equal to 0. All right, let's do the fourth one down. So I go back to y equals. I'm going to change x minus 4 to square root of x, close parentheses, close off the square root, and then do minus 3. I'm going to go to my graph, and this is going to shift down 3. So we're going to say shift or shifts down 3. Shifting down, this should change my y. So I'm going to hit second graph to go to my table. So here's error, so that my x is greater than or equal to 0, my y is greater than or equal to negative 3. X is greater than or equal to 0, y is greater than or equal to negative 3. All right, let's do the next one. Y equals. Again, the plus 3 is inside the square root, so we're going to do plus 3, close the parenthesis. We're going to hit graph, and this is shift to the left 1, 2, 3. I went to the left 3, so this is shifts left 3. Shifting left should change my x's, right? Let's not do that. It should change my x's. So I think the x's are going to change, but the y should say greater than or equal to 0. Let's see if that double checks. So I hit second graph to go to table. So I need to arrow up to where I see error in y2. Again, y1 is my parent function, so I don't want to do anything with that. Right below error, x is greater than or equal to -3. Y is greater than or equal to 0. X is greater than or equal to -3. Y is greater than or equal to 0. Okay, so let's continue this. Now we have a negative in front of my square root. Hit y equals. So now I need negative. Don't hit the minus, hit the negative. Negative square root of x. Close parentheses, get rid of anything else. Hit graph. And so this is going to reflect across the x-axis. So this is reflect across the x-axis. Okay. So what does this do to my x's and y's? If I go second graph to go to my table, here's error. It looks like x is going to be greater than or equal to 0. But watch what happens with my y's. Instead of it going like the x's, 1, 2, 3, 4, and positive numbers, this is going 0, -1, -1.4, -1.7, -2. The y's are actually going down. So at this point, I'm going to have x is greater than or equal to 0. Y is going to be less than or equal to 0. That's the big change, the big difference for this problem. The y's are actually less than or equal to 0. I'm going to take a step back and put in these graphs that I forgot to be graphing. The x minus 4 shifted right 4. Okay. The square root of x minus 3 shifted down 3. The one in green, square root of x plus 3 shifted left 3. The reflection reflected across the x-axis, so it does this. Okay, so now we're on 2 square root x. So we're going to go back to y equals, and we're going to do 2. I want to do it here. 2 square root x. Graph the parent function and 2 square root x. Now be careful. The starting point didn't change. The starting point is the same. So this doesn't do a shift. This does a vertical stretch or compression. Since it's larger than the original parent function, this is a vertical stretch. So we say that this is a vertical stretch. Vertical stretches don't change my x's and y's, so x is, well, it doesn't change the domain and range. X is greater than or equal to 0, y is greater than or equal to 0. And so that's going to start at the origin and then go up a little higher. The last one is 0.5 square root x. So I'm going to come back to y equals, and I'm going to plug in 0.5 square root of x. There's my parent function. There is the 0.5 square root x. This did a vertical compression. This is a vertical compression. Why? Because it's being compressed down. It's being compressed down. Vertical stretch is stretching up in a vertical sense. Vertical compression is being pressed down in a vertical sense. And my domain and range don't change. Okay. So that means that this is going to start at 0, 0 and then come up in a smaller fashion. All right. That is square root functions. Let's look at number 3. Number 3, use the table to answer the following questions. Make a scatter plot of the data. Find a function that fits the data. I'm going to scatter plot it on my graph first. negative point, excuse me, 0.5 and 2.3 will be right about here. 1.5 and 3.9 will be a little less than 4 right there. 2.5 and 5.1 will be right there. 3.5 and 6.0 is right there. 4.5 and 6.8 will be about there. 5.5 and 7.5 will be right around there. And then 6.5 and 8.2 will be right around there. Now remember, the one point that they don't give you that we need to remember is that we are assuming it is going through 0, 0. This is a square root function. So I need to put these into my calculator. So I'm going to go back to my calculator. I'm going to y equals. I'm going to clear out my y1, my y2. The nice thing is that on this table, I have a nice XY picture. So let's go ahead and get this into my calculator. I'm going to hit Window. My X's are going from 0 to 10, counting by ones. My Y's are going from 0 to 10, counting by ones. So that's my window. I'm going to hit second Y equals to go to the, no, that's the wrong place. I'm going to hit Stat. I'm going to hit 1 for edit. I need to change my L1s and my L2s. So this is going, I'm going to clear it out. So X is 0.5, Y is 1.5, excuse me. The next one is 1.5, then it's 2.5, and then it's 3.5, and then we have 4.5, 5.5, and lastly 6.5. So I'm going to go to L2, and this is 2.3, then 3.9, then 5.1, then we have 6.0, 6.8, and 7.5. And then finally, 8.2. So those are all my points. My L1 and L2 are the same length, so I'm not going to have any dimension mismatch. I need to turn on my stat plot, so now I hit second Y equals. Second Y equals. Hit Enter for number 1. I'm going to hit Enter to turn it on. This is already a scatter plot, and now it's my X list is L1, my Y list is L2, and my mark is a little box. So I'm going to hit Graph, and there's my points in the graphing calculator. Now I need to guess at a square root function. I know that this function is going to be Y equals something square root of X. I need to figure out what that something is. So we're going to go to Y equals, and I'm just going to start with the square root of X. And I'm going to hit Graph. Well, that's clearly too small. So I'm going to go back to Y equals, and I'm going to guess 5 square root of X. Hit Graph. That's too big. Now, I don't want to cut it in half, so let's try 4 square root 5. Still too big. Okay, let's try 3 square root 5. Too small. So then let's go to 1 decimal place. I'm going to scoot over here, and I'm going to hit second delete to insert, and I'm going to insert 0.5. Well, 3.5 was too big. So let's try 3.2. That looks like that's it. So that tells me that it's Y equals 3.2 square root of X, and that's going to give me a line that pretty much did that. Okay, let's go to the next page. Last page, front of the last page. Inverses. Graph f of x equal to the square root of x minus 2. Using the table on the grid provided. So here I give you x's, plug in 2. The square root of 2 minus 2 is the square root of 0, which is 0. The square root of 3 minus 2 is the square root of 1, which is 1. The square root of 6 minus 2 is the square root of 4, which is 2. And lastly, the square root of 11 minus 2 is the square root of 9, which is 3. Plot these 4 points. These 4 points are 2, 0, 3, 1, 6, 2, 8, 9, 10, 11, 1, 2, 3. Okay? There's my graph. Okay? State the domain and range. Well, remember, since this is a square root function, my domain and range deal with this very first x and y. So my domain is x is going to be greater than or equal to 2. Y is going to be greater than or equal to 0. Okay? State the domain and range of the inverse. Remember, if I'm doing inverse, I switch x's and y's. So x is greater than or equal to 0. Y is greater than or equal to 2. Sketch the graph of the inverse on the same grid in a different color. I'm going to go ahead and use red. Remember, the inverse, I switch x and y, so 2, 0 becomes 0, 2. 0, 2 is right here. 3, 1 becomes 1, 3. So this is 1, 3. 6, 2 becomes 2, 6. And 3, 11, 3 becomes 3, 11. So this is 3, 8, 9, 10, 11. There's my inverse. Okay. Lastly, find the inverse function. Remember, with the inverse function, what I've been saying is change f of x to y is equal to square root of x minus 2. To find the inverse, you switch x and y and solve for y. The the y minus 2 is inside the square root. There's nothing outside the square root on this side of the equal sign, so I square both sides. X squared is equal to, well, the square and the square root cancel, leaving y minus 2. I'm going to add 2 to both sides, and I get y is equal to x squared plus 2. That is my inverse function. Okay? All right. Next problem. Don't know why I skipped to number 3. Okay. Find the inverse of the following equations by switching x and y and solving for y. Graph the original function and the inverse of the same grid. So I'm going to start by graphing the original function. Remember, these are in the form y equals mx plus b, where I have a slope and a y-intercept. My y-intercept here is 0, 0. My slope is 4 over 1. So I'm going to go up 4, right 1, up 4, right 1. Or I can go down 4, left 1, down 4, left 1. There's my original graph. Now I need to do the inverse, so I'm going to switch x and y and solve for y by dividing by 4. So y is equal to x over 4. Now remember, we like to have our slopes in front of the x, so I'm going to remember that there's a 1 in front of that x and write it as y equals 1/4 x. That tells me my y-intercept is 0, 0. My slope is up 1, right 4, up 1, right 4, or down 1, left 4, down 1, left 4. There is my inverse. Letter B. Again, let's graph the original picture. My y-intercept is -2, so here's the coordinate 0, -2. My slope is up 3, right 1, up 3, right 1, up 3, right 1, up 3, right 1. Or I can go down 3, left 1, down 3, left 1. Okay, so here is my line. Now I need to find the inverse, and to find the inverse, remember this was 3 over 1. That's where I got up 3, right 1. The inverse, what you need to do is you need to switch x and y and solve for y. So we're going to go ahead and add 2 to both sides of the equal sign. X plus 2 is equal to 3y. Divide every term by 3. So you get y is equal to, remember there's a 1 in front of this x, so it's 1/3 x plus 2/3. My y-intercept is 2/3. Well, that's just a little less than 1. And from there, I want to go up 1 and right 1, 2, 3, a little less than 1. Up 1, right 1, 2, 3, a little less. Up 1, right 1, 2, 3. And again, I'm not right on the line. I'm a little less than the line. Down 1 over 1, 2, 3. Down 1 over 1, 2, 3. And down 1 over 1, 2, 3. There is my line. Okay? So I have my equations. I have my pictures. Let's do my last one over here. Graph the original one. So my y-intercept is 2. So that's 0, 2. My slope is down 2, right 5. Down 2, right 5. Or I can go up 2, left 5. Up 2, left 5. There's my original graph. Okay. Now I need to find my inverse by switching x and y. So x is equal to negative 2/5 y plus 2. First thing I'm going to do is I'm going to subtract 2 from both sides of the equal sign. So x minus 2 is equal to negative 2/5 of y. Now 2/5 of y, to get rid of that times 2/5, I want to multiply by its reciprocal, negative 5/2. I flip the fraction, the sign stays. The sign stays. What I do to one side, I have to do the other, but I need parentheses on this left side. So negative 5/2 is going to be distributed into the x and into that minus 2. Over here, the negative 2/5 and negative 5/2 cancel, leaving y. Negative 5/2 times x is negative 5/2 x. Negative 5/2 times a negative 2 is a positive. Now that's 2 over 1. So negative 5 times negative 2 is positive 10. 2 times 1 is 2. That then reduces to y is equal to negative 5/2 x plus 5. So my y-intercept is 5. I'm going to go up 1, 2, 3, 4, 5, right 2. Or I can go down 1, 2, 3, 4, 5, right 2. And down 1, 2, 3, 4, 5, left 2, by the way. I am moving 1, 2, 3, 4, 5, and moving left 2, but I was saying right. And there's my inverse. On all of these, if you're unsure if you're doing it right, remember what you can always do, to get myself a little more room, is you can always draw in the line y equals x. And when you draw on this line, these two lines should be symmetrical. If you draw the line y equals x, these two lines should be symmetrical over that line. Where they cross should always be on that line. We'll use a different color for this last one. Again, now it looks like I'm a little off on this one, so let me double check I didn't make a mistake. And that's why I wanted to check this one, because something seemed awry. I'm going to pause for a minute. So on this third problem, something didn't look right to me, and it's my graphing. I made a mistake with my graphing. Let's get rid of that, what I just drew there accidentally. Okay. Sorry about this. Okay, I'm going to hit undo, undo, undo. Okay. So this line, I made a mistake on. So let's get rid of this. These points I made a mistake on. So I'm going to get rid of them. Where was my mistake? Oh, that's my line y equals x. Again, that was my check because it didn't look right to me. I felt like I had made a mistake somehow. So again, what I did was my y-intercept was correct as 5. My slope is not 5/2. It's negative. There's a negative right there above that equal sign. It's negative 5/2. So if I'm going to go up 1, 2, 3, 4, 5, I have to go left 2. And if I'm going to go down 1, 2, 3, 4, 5, I have to go right 2. And down 1, 2, 3, 4, 5, right 2. Down 1, 2, 3, 4, 5, right 2. That's what my line should have looked like, or needs to look like. It crosses on the line y equals x. That's a better reflection. And I check that to make sure that reflection is right, because otherwise I know I made a mistake somehow. All right. Last portion of what we're doing is pendulums. So let's look about pendulums. Let's see how this works. Remember, the relationship between the length of a simple pendulum and the period of the pendulum is described by the following equation. The period is equal to 0.2 times the square root of L, and it's measured in seconds. This word seconds has been confusing a lot of people. This is the equation. That's telling you that the measurement is in time, is in seconds of the period. But don't let that confuse you. Use your function to predict the period for a pendulum that has a 100 centimeters in length. So that tells me, and I'm going to do number 1 over here, that my period is equal to 0.2 times the square root of 100, where the square root of 100 is 10. So this is 0.2 times 10. So go to your calculator. Second mode to quit. So this is 0.2, and if you want, do by the square root of 100. And it gives me 2. So that tells me my period is 2 seconds. 2 seconds. Okay? Now, number 2. How long should the pendulum be if the clockmaker wants the period of the pendulum to be 4 seconds? So my period is equal to 0.2 square root of L. I want my period to be 4. So this is 0.2 square root of L. I need to get L by itself, so I'm going to divide by 0.2 to both sides. So here I'm going to say 4 divided by 2/10, or 0.2, is 20. So 20 is equal to the square root of L. I want to get L by itself, so I need to square both sides, because the square and the square root cancel, leaving L on the right. 20 squared is 400. So that tells me that the length of the pendulum needs to be 400 centimeters. That's our review. That's the entire review. This did take me a while, so this is not something you can do, just sit down and do. That's why we are having a couple days in class. Have a great rest of your weekend.